Go ahead and get your calculator handy. You're going to need it. Let's start looking now. So we got 4 basic functions that we're going to look at sketching the graphs, the transformations. So we're hoping that for each of these, I don't really need to, I can just give you the equation, you can tell me what the picture looks like, right? So x squared, just basic x squared, what does that graph look like? Parabola that goes through the origin, right?
Yes.
And opens up. So if we want to graph x squared, we know this is the basic graph. So if there's one point I was going to keep up with, it would be the origin, 0, 0. All right, what does x cubed look like?
Yeah,
it's a squiggle, but it doesn't have any hills or anything. It just kind of squiggles through like that. All right. What about square root of x?
It starts in the origin and just goes on.
It's the top half of an open right parabola, so it goes like this. Notice they all have 0, 0. Okay. And then the last one is absolute value of x, which I know you guys know. It's just your V shape. So what we're going to look at are the transformations of these graphs and then maybe just transformations in general. So how do we know when a graph is going to, so the first thing we're going to look at is shifting vertically. How do we know when the graph will move vertically? What's going to tell you? Like what changes in the equation?
X is positive or negative.
All right, so notice.
No, never mind, sorry.
First I want to make sure, this in here tells you how you get what?
Up or down.
All right, you're thinking too much. Think very basic. Take it back a couple notches. When you have an equation, this over here.
What the picture looks like.
Yeah, but it tells you how to get what? The y's. That's how you get your y's. You square x. So the right-hand side is how you get your y's. Okay? So like for instance, if I made a regular t-chart for x squared, right, maybe I would do -2, -1, 0, 1, 2. If I wanted to plot points, how do I get my y's? I square the x. And I get 4 when I plug in a -2, and I get 1 when I plug in a -1. And I get 0 when I plug in a 0. So what I want to make sure that's clear is that this is how you get your y's. Okay? So my question is, and you can use your calculator on these so we can kind of investigate. If we did x squared plus 2, what would that graph look like? Why does it move up to? So yeah, go ahead.
It's just the y-intercept plus 2, so it's going to be.
That's one way to look at it. Remember, x squared was how we got our y's before. And what are we doing to x squared? So guess what we're adding 2 to? All the y's. Every y's. That's why the whole thing moves up 2. Because look, if we made a t-chart for this one, I'll do the same x's, -2, -1, 0, 1, 2. All right? Look what happens. When I plug in a -2, I still get 4, but it's 4 plus 2, which is 6. So it's not just affecting the y-intercept, it's affecting everything. When I plug in a -1, I get 1 plus 2, which is 3. So I'm still squaring, and this 4 and 1 were the original, the y's on the original. 0 squared plus 2, we get 0 plus 2, 2. 1 squared plus 2, we get 1 plus 2, 3. And if I do 2 squared plus 2, 4 plus 2, which is 6. So if you look at all of these y's, and you look at the original y's, the y's over here are how much each one of those? 4, 6, 1, 3. 0, 2. There's your y-intercept, 0, 2. But look, each one of these are how much of, the ones over here are how much of these over here? Too high. So, yeah, but so if we want to sketch it, then Hank's right. Just move one point, which is the y-intercept. That's the easiest one to move, and that should be your picture. Okay? So a number on the outside, we'll move it up and down. All right, so let's see this. Let's see if you can do this one. What is, and I just put the t-chart there, Jeff. So here's this one. What if we wanted to graph x cubed minus 3? So notice again, I put a minus 3 on the outside. What is this graph going to look like? It'll move down 3. So I'll take this guy and move it down 3. And Hank said the easiest point to move is which one?
1.
Yeah, so I'm going to move the origin, which is at 0, 0, and it's going to move down 3. And then you just redraw the picture. Okay? All right. Because, again, what gives me my y's? X cubed is how we got our y's. And if we do x cubed minus 3, we're subtracting 3 from all the y's. That's why it moves down 3. Okay. All right. Okay, I'm going to erase this. Like, I need to, maybe almost done with those points there. I want to leave this picture here. Okay. So look, we'll do a little check here. So I'll put the, I'll put an equation on the board. You see if you can graph it. So that's right. So x cubed minus 3 would be the x cubed graph down 3. We've got that. All right. Could you do also absolute value of x plus 5? And could you do square root of x minus 2? So could you just sketch those really quick? See if you can do each of those. All right. So what's the basic graph of absolute value of x? What does it look like? A V. And if we do plus 5 on the end, it's going to move where? Up 5. It's like that, and I redraw it. Okay. All right, and then, so there's that picture. Then what does square root of x look like?
Half of a parabola.
Top half of a parabola. And if we do minus 2, it's going to move where?
Down 2.
So I'm only moving that origin point, and then I'm just redrawing. Okay? So now let's generalize. It's supposed to be C here. Let's generalize vertical shift. So vertical shift, if I have whatever function it is, if I do plus C, let's just assume C is like a positive number. Because I'm trying to generalize it for any graph. So instead of me putting x squared or absolute value of x or square root of x, I'm just going to say f of x. So if I do a graph plus C, it's going to move where? Up C units. All right, and if I do f of x, so a basic graph minus C, where does it move?
Down.
Down C units. Okay. All right, because look at all these. See, again, when I wrote this equation, like that's my basic graph, f of x plus 5. That's my basic graph, f of x minus 2. All right, so what's next? So now if it'd be okay, I'm gonna erase, I need room, so I'm gonna erase all those basic graphs. You have those in your notes. You probably should know them. Okay, so hopefully you've got those memorized. All right, so now horizontal shift. And I think of horizontal shift similarly to what you were thinking, Hank, on the y-intercept. So I think about horizontal shift pretty similarly. All right, so let's say we want to, so we're looking at horizontal shift now. And so let's look at what happens when we do these. So we'll call this example 2. All right, let's say we have x minus 2 squared, or let's say we have absolute value of x plus 3 on the inside. Let's say we have square root of x minus 1, all right? So first of all of these are going to be a horizontal shift. Where do you notice the numbers are at? The minus 2, the plus 3, the minus 1, they're all where? Inside. They affect the x first, okay? So now, first of all, before I do each one, do you recognize what the basic equation is? Like on 2a, what's the basic graph? We call it like the parent function. What's the one it relates back to? So again, at the start of the lesson, I gave you 4 basic graphs. What I'm saying is this shape is going to look like which one? X squared, but it's going to move. It's going to be a shift of the x squared. Okay. So I'm telling you that this is a horizontal shift. The question is, which way does it shift? Right or left?
Right. It shifts right too.
Okay.
Oh, I'm looking at the wrong one.
Yeah, part A.
Okay.
You said left, she said right, he said right. Or then why is it right? Why do you do the opposite?
That's what you're supposed to do.
Okay. So let's think about this. So we all agree, you're right, but you need to, maybe if you understand why, it'll help you a little bit. I'll show you. Everybody agrees that the basic graph, x squared, right, this is the point 0, 0. Okay? Notice, let's say I'm not sure where this is going to move. I'm not sure if it moves right, or I'm not sure if it moves left. I'm kind of in between. As I see a minus, I'm thinking, well, maybe it should go left, because when we did a minus on the outside, we went down. But whether it moves right, or whether it moves left, whichever way it moves, what do you know about the y coordinate? If it moves right, what's the y going to be? And what is it going to be? 0. If it moves left, what's the y coordinate going to be? 0. For this point. So what my point is this, is if you think for a second, say, okay, what am I going to plug in for x so that I get 0? Because it's got to be something, comma 0. See, so at this point, if it moves, whichever way it moves, left or right, that's by me plugging in the x. So I'm going to think, well, what do I plug in so that the answer is 0? What would we plug in? What number can you plug in so that you get 0? There's the answer. That answers your question. If it was at 0, 0, how do I get 0 again? Because if it goes right or left, your y is going to be 0. Well, how do you get that? Well, only if we plug in a 2. If we plug in a 2, we get to 0. That's where it goes. Right. I'll do it again.
I'm just gonna. I know
Yeah,
that
but
you've been
what
right.
I'm saying is, but what you're doing is not good enough, because you'll end up forgetting. If I can get you to do, if I can get you to know the why it happens, then I think it will help you. Okay. So just be patient.
If it's positive, you get a left.
I know, but that's you're right. That's what it is. But there's a why. Why is it that it goes left? See, I'll show you. Okay. Let's do the part C. Just bear, but here's the thing. Bear with me and try to see what I'm showing you. Okay. I think I can sell you on the next one. Because really, there's only. Okay. So let's do part C. So first of all, notice there's nothing on the outside. Outside, it moves where?
No.
If there was something on the outside, where would it move?
Up or down.
Up or down? Okay, so there's a -1 on the inside. So the question is, where does it move and why? So, all right, so look. Here's my basic graph. Do you agree with this? My basic graph is, that's what it looks like. And it has the point 0, 0.
We're doing C.
I'm doing C because this I can sell you on this one, I think. I think I can get it.
Okay.
Okay. All right, so let's just pretend. So here's what I want you to do. Take that rule out of your head that you said, well, if it's a plus, I go left. If it's a minus, I go right. Just forget about that rule for a second. Just take a fresh look. All right, so we're gonna graph this one. Let's pretend we're not sure. Let's just say we're not sure if it goes right or left, correct? We know it's gonna go horizontally. It could go right one or it could go left one, okay? So again, how do I get, it's all about looking at points. So if I made a T-chart for this graph, I would do 0, 1, and 4 to start with to get my points. Because I can, and maybe even 9 for this graph, because I can do square root of 0, I can do square root of 1, I can do square root of 4, I can do square root of 9, and I get my points. So this graph has the point 0, 0, just plotting, I'm just doing this one. This one has the point 1, 1, 4, 4, 2, and so on. All right, you see those? Okay. So the question is, where does it move? We're pretending we don't know the little trick, right? So look, if I want to get points, I'm going to run out of room. I'm going to speed this guy up a little bit more. If I want to get points for this one, if I want to generate the points, ready? We generate points by picking x's. So tell me an x that we should plug in. Just pick an x. Okay, sure. I'm so glad she said that. Because this is where I'm gonna get you. This is where you'll learn. She said, can you not use the same x's? Sure, I'll go ahead and use the same x's. 0. Yeah, square root of 0 minus 1. What happens?
Oh.
Square root of a negative.
So 1.
Okay. So we can't use the same x as before because if I do, I get a negative.
And then you can't score.
So here's my question for you. These were nice to get on the inside because they're all perfect squares. So my question would be for you, because I know you're a smart cookie because we've been in here doing finite math together or whatever that mess you made me do, right? The linear programming. So let me ask you this. What would you pick for x so that on the inside, see, because it's a square root, I don't want to have a nasty number. I don't want to have a 3 on the inside. Would you guys agree with that? I don't want to have a 3 because I can't do square root of 3. But can I do square root of 0? So what would you pick so that we would get square root of 0?
1.
Yeah. Square root of 1 minus 1 is square root of 0, which is 0. So there's a point. All right. What would you pick so that you did square root of 1? Yes. What would you pick so that you did square root of 4? 5. And what would you pick to go square root of 9? Now remember, these are your x's and these are your y's. What do you notice about the y's in this graph and that graph? They're the same. But what did Sydney have to do to get x's that gave the same y's? Look at your original x's here and look at the x's she picked. Added 1 to all of them. Or 1 to which way? To the right. So it moves right because so here's the easiest place to see it. That point 0, 0, where does it go? It goes here. 1, 0. Right. Why does it go right? Because I have to plug in a 1 to get 0. That's why it goes right. And then of course all the other ones follow. So again, And there's your new graph. It moved right one because you had to pick x's that were one bigger so you would get the same insides. So 1, 2, 5, and 10 are one bigger than each of those, and that's why it moves right. But the easiest one is just that 0, 0 point, see? So like look at this one. Okay, same idea. Here we can do this one quickly. The basic graph has 0, 0, right, of the V. So what do you gotta plug in here to get 0 again? There you go, and that's why it moves. Because you said, well, if it's a plus, I go left. That's why you go left. Because the -3 will now give you that same 0, and that's where it goes. Did that help a little bit?
Yeah.
Okay, you don't have to lie, but I think, usually this is where I can sell you on this one.
It's just so what you plug in to get the 0.
That's right. Because that's how
If it's a
you,
negative, then you go left, and then if it's a positive, you go right.
right, you plug in a -3, because I'm trying to track a point. Where does a point end up? Because this is the old graph. This is the new graph. So I'm trying to compare them. So that's the easiest point to track its movement. Okay? That's how I think about it. I don't know if that helps, but that's how I do it. Yep. Rather than just, yes, the memorization is right. Plus on the inside, I go left, minus on the inside, we go right, but I wanted you to see why. So if I just made up some silly graph, here we go. Here's a silly graph. We're gonna call this graph g of x, okay? And let's say g of x is this graph here. It's like this shape, okay? Kind of, I don't know what it is, I just made it up. So if I said do g of x minus 2, and the -2 is on the inside, according to what you said, right? And so here's your 0, 0. So where should this point move? To the right 2, and then you would just redraw it, okay? All right. If I did this, then what would it do?
Go up 1.
Up 1. Okay? So, did somebody have a question? Were you raising your hand? No? So, horizontal shift. You got it. So that's how I write horizontal shift. I put it like on the inside of the parenthesis like this. Okay? F of x plus c and f of x minus c. So if it's a plus on the inside, we shift left. And if it's a minus on the inside, we shift right. All right. So now you should be able to do two graphs at once. So see if you can sketch this. So we'll call this example 3, sketch. I'll put a couple of these. Can you do x minus 3 squared minus 2? And can you do square root of x plus 2 minus 1? So see if you can sketch each of those. You can use what you were saying, because it's right. So now it is 2. So inside is horizontal and outside is vertical. We'll look at each of these pictures. All right. All right, Jordan, can you tell us where you think the first one moves?
Your right 3, and then down 2.
And what shape is it? Yeah, there's that. Done. Got it. Okay. Right 3 down 2. Is everybody good with how we got there? This kind of a review also. All right, so there's that one. All right, second one. First of all, what's the basic graph, Leah? What does it look like? Yeah? No.
No.
Draw it again with your finger. Just finger draw it for me. No, it doesn't squiggle up.
Doesn't swivel up?
No. Top half of a parabola,
Okay.
just like this. Okay? So where does it move?
Where does it move? So it goes over two to the left two,
Yeah.
and then down one.
That's very good. Okay. So I think right now we've got vertical and horizontal shifts down. Okay. Now, let me ask you a question. What if I just gave you a graph? So I need to erase here in a second. So can I erase? Have we got it? Okay. What if I just gave you a graph? So let's just say I made up this graph. So now we'll go to example 4. Let's say I said that f of x is 2x squared plus x. So now I've just made up a graph. You're not sure what it is, but if you were gonna guess, what do you think the shape, what do you think this would look like? Yeah, it's a parabola.
Would it be skinnier?
It would be skinnier, but you don't even have to do all that.
Oh.
So here's what I would say. If I asked you to move f of x down 3, what would you do? So here's the point. This now is your graph, and you gotta move this graph down 3. So how do we know that we moved down 3? Yeah, or whatever it is, you just need to subtract 3. So all we're gonna do, we're gonna say, all right, here's our new graph, 2x squared plus x minus 3. Put a minus 3 at the end. Okay? That's gonna move it down 3. Now you could type it in on your calculator and check. You could graph that, you could graph that. All right? What if I wanted to shift left 3? And you said left on the inside should be what? What should be on the inside? Plus 3, but inside where? So notice, it should be not only here, but it actually has to go there. So wherever you see an x, you gotta make it an x plus 3. So what we gotta do, if we wanna shift left 3, we've gotta actually do f of x plus 3, which means we gotta put an x plus 3 wherever we see an x. So here's what I want you to do real quick. In y1, graph this, 2x squared plus x, get that picture. And then in y2, graph this, and don't simplify, just leave it, so you put your x plus 3 squared plus x plus 3, just like this. And see, if it is this graph, move left 3. So take 2 seconds and plug this and plug this. And what's weird is, since there's more than one x, I've got to put an x plus 3 in both spots. Just to verify.
Just move to the left.
Yeah, that's it. But yeah, it had to go in both spaces. Okay, yeah, it has to go, yeah. I just wanted you to verify. Yeah, I just wanted to reassure you that that's what it does. Notice, since there's more than one x, I have to put the x plus 3 in both, so that the whole thing moves left. Okay? All right. So here we go. I'm going to give you a problem. Here's example 5. Given, let's just say g of x is x squared minus 3x plus 1. This is the graph. This is your basic graph. So part A, shift g of x up 4 and shift g of x right 2. So come up with the new equations for each one of those. All right, rewrite it, just put y equals what should happen, and then we'll go from there. So you're taking this picture and moving it up 4, okay? You're taking this picture and moving it right 2. So let's see if you can write. Probably the first one you can simplify, but the second one don't simplify. All right, now we'll put our answers down here. Okay, So what do I need to do to G to move it up 4? Add it to the end. So at the end, notice there's already a 1, that's fine, you just add 4 to it. And so your n now should become plus what? That's it. That's exactly right. And here's what you can do, just type it in. Here's the old one, here's my new one, did it move up 4? You can just graph it and see. All right, how do you move right 2? The inside needs to be what? So it's got to go for both x's. So you'll do x minus 2 squared minus 3 times x minus 2, and then it's still got a plus 1. Don't worry about multiplying that out. Just leave it like this. No, it's 2 separate problems. That one is, because this is your G. This said shift G up 4. That's one problem. This says shift G right 2. Going back to this is your G. I'm not doing 2 things at once. I'm doing 2 separate problems. Okay? It's only a plus 5 if I move up. This isn't saying move up 4 and move right 2. It's doing 2 separate. Yeah. Okay. Last thing. Reflections. What are reflections?
When you flip it, right?
Yeah, when do you do that?
Right, mirror it.
When do you do that?
You say when?
Yeah. When does that happen?
When you like multiply by a number?
What type of number? You're getting warmer and warmer each answer. A negative. Yeah, negative causes reflection. So on all of our graphs, if I did negative x squared or negative absolute value of x or negative x cubed or negative square root of x, if I put a negative in front, what does it do? If you're not sure, check on the calculator. Flips it where? About the, yeah, not necessarily down, it just flips it about the x, because you're gonna see on this one, part of it's already down and it goes up. So yes, so negative x squared looks like this. You're right. Now remember, Hank, this was the first question I asked you today. What does that give you? This was the very first question I asked. What does the x squared give you?
The x squared.
No, it does not give you the x squared. It gives you your y's.
Ah, dang it.
Because that's how you get your points. You pick an x, you square them, that's how you get your y's. So what's it gonna do to all the y's if I put a negative in front? Well, it's gonna make them opposite. So if they were all positive, now they're all negative. See, there's that. Here, absolute value of x, same thing. This is what gives you your y's. If you put a negative in front, they're all negative now. Opens down. Now negative x cubed, sorry, I'm running out of room. We'll put negative x cubed here. Now notice, I'll put in dash the x cubed. So see, this part was already down, so where is this part gonna go? It goes up, and this part goes down. So there's negative x cubed. I call it rotisserie chicken. Okay, like that, rotisserie chicken, because I'm hungry, and a rotisserie chicken would be great right now. Maybe you don't. Last one. Can you finger draw this one? That's it. It's underneath like that, because it was like this. So it's a mirror image about the x, because all the y's got negated. Okay? All right? What do you do if you have a negative on the inside? So what happens if we have a negative on the inside? So if we do negative x quantity squared, or absolute value of negative x, or negative x quantity cubed, or square root of negative x. What does a negative on the inside do? Yes? It does flip. So here, negative in front flips about y-axis. I'm sorry, x-axis. You're right. Yeah. I can't talk. And over here, believe it or not, it flips about the y. And here's the best one to show you. Here's where I can kind of prove it to you that it flips this way. Because remember the t-chart that we had for basic square root of x. Remember we wanted perfect squares, 0, 1, 4, 9. And we plugged all these in. And we got 0, 1, 2, 3. And we got our graph, so our basic graph. So 0, 1, I'm just going to do 1 and 4. And we got 1 and 2. Here was our points. Okay. So I wanna show you what happens if this is our function, right here. I'll do the T-chart for this. I can still do 0, because it's got a negative in here, because I can do -0, and I still get square root of 0, which is still 0. But notice, you can't have a negative inside of a square root. So you gotta get rid of the negative somehow. So look, I would like to do square root of 1, so my question is, what do I pick for x so that I get square root of 1? And this is why it flips about the y. Because if you pick a -1, when you plug it in, a negative times a negative becomes positive. So notice here's your point. Still got 0, 0, but you got -1, 1 now. So this is the best one to see that it flips about the y. These two also flip about the y, but you can't tell anything. Because look, if you take a parabola or a v, and you flip about the y, what happens? The same. Take -x squared, a parabola, flip it about the y, what happens? Now this one, if you flip it about the y, you can see the difference, okay? All right, so when you do your transformations, here's the order you do them in. So now let's say I have like a negative in front, so just to put it all together now. Let's just say we had this problem. I always do my transformations from left to right, and I always do flips first. Okay, that's the first thing that I do. So, a negative in front, we said flips where? About the x, so I'll do that first. Then I do what this says and what this says, and I'm done with it. I have it. So where does a -4 on the inside do? Right 4, and then what does a +1 do? There's your picture. Okay. Always do flips first. And I'll summarize these reflections real quick. All right, so if we have negative f of x, negative in front, we flip about x. Very good. And if we have f of negative x, negative on the inside, we flip about y. And that's 3 5. That should pretty much do it. I think a lot of this review for you. So. Very good.